Hello everyone, welcome back to Algebra 2 Lesson 4. Today we'll be learning radical expressions and equations, and we'll be learning how to simplify radicals. We'll be learning about imaginary and complex numbers, solving radical equations, and the graphs of radical functions. So let's get started. So first of all, we got the definition of radicals. The square root of a number is the thing that must be multiplied by itself to get that number. The symbol for the square root is this little sign right here. It's called the radical sign. Okay, so in this case, an example is what is square root of 25? That'll be 5, since 5 times 5 equals 25. Okay. In this case, negative 5 squared also equals 25. However, the positive number is solely within the radical symbol. Numbers that are not perfect squares still have a square root. So, radical 7 equals 2.6457751. When there is a small number outside the radical sign, it is no longer called a square root. So, say, for instance, there is a 3 outside the radical sign. So, this would be called a cube root. So, cube root of 64 is 4. And this makes sense because 4 times 4 times 4 would equal 64. Okay? And one last thing, if there is no index number, we call the number outside the index. If there is no index number outside the radical, we consider it to be a 2. Okay, we'll be learning multiplying radicals. When two radicals have the same index, numbers within the sign can be multiplied. So, for example, radical 4 times radical 9. In this case, the radical is you just combine the numbers within the radical, so 4 times 9, and that would be the square root of 36, which is 6. The general formula, or form for this, is radical A times radical B would equal radical A times B. Okay. And next we have simplifying square roots. If the number inside the square root has a factor that is a perfect square, the radical can be simplified. So, say for instance, radical 50. This can be simplified because the one of the factors of 50 is 25, which is a perfect square. So in this case, you can split it up like this. Radical 25 times radical 2, and that would be radical 50. And then going further, your answer simplified fully will be 5 radical 2. Since this is a perfect square and radical of 25 is 5. And then we got example 2. Radical 9, what would be the final answer for that? Oh, sorry, this would be radical 18. Okay, radical 18, you would split it up to radical 9 times radical 2 as a factor of 18 would be 9. And since 9 is a perfect square, it becomes 3 radical 2. Next, we have adding or subtracting radicals. Radicals can be added / subtracted if they have the same index and the same number within the sign. Okay, so we can add these two. The index are the same because we assume the blank little space to be a 2. This would also be a little 2. And the number within the sign, which is 2, is the same. So in this case, you can just add them straight up. And that would become 7 radical 2. Next, we have 8 radical 3 minus 6 radical 3. The same process applies, same index, same number within the radical sign. And then you simply just subtract 2 radical 3. Okay. In some cases, you may get like a more complicated problem, and you have to simplify these on your own first before adding. So, the factor of this would be radical 25 times radical 2 plus, and then what would be the factors of these, which would be radical 9, radical 2. And then simplified further, 5 radical 2 plus 3 radical 2. In this case, the result will be the same as this formula right here. Or not formula, but a problem. So again, you just simply just add. So 8 equal 2. That'll be your final answer. Okay, next up we have imaginary numbers. So the square root of any negative number can be represented as an expression involving this I. It's just a regular I just put a tail right here to distinguish it. So, example 1. The square root of -9. Which would be, since this is a perfect square, 3. And there's a negative also, so that negative turns into an I. So 3I. I is basically -1. So 3I. Okay, next up, or sorry, not -1s, square root of -1, my bad. Example 2, we got square root of -7. What would that be? That would be I radical 7. There you go. And that's simply it. Remember that I is just radical -1. Okay, next up we have adding and subtracting imaginary numbers. So we generally consider like I terms to be like terms and can be added / subtracted. So let's say 5I plus 2I. That would simply be 7I. But if you are adding, like, let's say 3 plus 3I, it would not work. You just keep it in this form. Okay? Moving on. We have multiplying imaginary numbers. So all in all, the procedure to multiply imaginary numbers is very similar to multiplying just regular expressions. So 5I times 2I. This is exactly the same as 5x times 2x. And what would this be? 10x squared. So what would this have to be? 10I squared. And since I is square root of -1, we could rewrite -1 like that and squared. And since there's a square root and a exponent of 2, since you are squaring it and there's a radical, these both cancel each other out, so they just don't exist anymore. And the result will be -10. Okay. I'll get a little further into what happened here later on. It will be the next little subtopic. So let's just try out this next example. Example 2. So what you have to do, 3I radical 2 times 5I radical 3. What you have to do, is combine these outsides, 15I squared, and then combine the number inside, so 6. And once again, I squared is just -1, so -15 radical 6 would be your answer. What we have here is what we just looked at briefly, like I squared. So it's called the powers of I. So I can be raised to other powers besides 2. The possible values of I raised to an integer are I, -1, -I, or 1. And this applies for any number. Like let's say I-27 or I-45. You can just simply plug in your calculator and you get one of these 4. And I drew a little table to clarify. So I to 0 is 1. Right here. I to the 1 power is I. I to the second power is -1. I to the third power is -I. I to the fourth power is just 1. Very simple. If you're confused about how I got this one, let's say, it's basically just I times I times I. And what is I? It's the radical -1. Radical -1 and radical -1. So, -1. and this is just I. You don't have to convert, so it's just negative I. That's how we got that. And this applies for all. And you can also use a calculator to figure this out as well. Let's see here. If you just press second and this period or this dot, and you get I. And then I to the 47, and blah blah blah. Okay, moving on. We have complex numbers. So when a real number is added to an imaginary number, the form remains in a plus bi. So bi, this would be the imaginary number, like 5i, let's say, for instance, and the real number is just a regular old plain number. Okay, so let us try 3 plus 2i plus 5 minus 7i. It's really simple. You just combine like terms. 3 plus 5, 8. 2 minus 7, negative 5. So 8 minus 5i will be your answer. And for the next one, don't forget, this one's a distributing case. So rewrite minus 5 plus 7i. And once again, combine like terms, negative 2 plus 9i. That'll be your answer. Okay, moving on. We have multiplying complex numbers. So basically the process is just a FOIL. Anytime an I squared appears, it becomes negative 1. So let's say, for instance, example 1, 3 plus 2i times 5 minus 7i. What you have to do, FOIL. Or what I just like to do, just make sure everything is just multiplied with each other. So 3 times 5, 15. 3 times negative 7 minus 21. 2 times 5 plus 10i. And then 2 times negative 7. So it's just negative 14i squared. And in this case, I squared is negative 1. Okay, just forget that. So 15 minus 2i, or just combine it straight up right now, minus 11i plus 14 in this case actually. That would be your final answer. Wait. Oh, sorry. You have to like simplify further. Forgive me. It's very tired right now. That will be your final answer. Sorry about that. Okay. The next one, 3 minus 4i times 2 plus 5i. What you have to do, I'll just skip the process since you're probably familiar with it already. 6 plus 15i minus 8i plus 20. This would be simplified down to 26 plus 7i. And that's it. Moving on, we have complex solutions to quadratic equations. So if a negative number appears within the radical, the quadratic equation is said to have two solutions. So once again, the quadratic equation, it was one of the other lessons that I did prior. It is x equals negative b plus or minus square root of b squared minus 4ac over 2a. That's your general form. Right? So let's apply to this. So x equals negative b plus or minus 4 squared minus 4 times 1 times 13 and 2 times 1. And simplify it. 4 plus or minus negative 36 over 2. And c in this case is special because there's a negative within the radical, and so this would just simply become 4 minus plus or minus 6i over 2. And then go further, 2 plus or minus 3i. That's your final answer. If you're confused on how I was using this, I made a video on it previously regarding quadratic equation, so you can check that out. But generally it's just in this form: negative b plus or minus square root of b squared minus 4ac over 2a. And that's all. Next, we have graphing complex numbers on a complex plane. So numbers like 2 plus 3i cannot be graphed on a standard number line. They are graphed on the complex plane. The complex plane is basically just a 2-axis coordinate plane. So this y-axis is replaced with imaginary. So like, let's say I, 2i, 3i, whatever, so. This is just real numbers right here, 1, 2, 3. And so if you have like 2 plus 3i, so 2, bam, over here, and then 3i. Simple. That's it. Next up, we have one-step radical equations. So when you square the square root of a perfect square, the result is the number under the radical. Very simple. It's just when you square, like let's say for instance, example, the square root of 9 and then squared is just 9, because you see there's a square and there's a square root and they cancel each other out, so the only thing that's remaining is a number on the radical. So let's try it out. This can be applied to equations. So radical x equals 9. What do you have to do? First, you always have to cancel this out, this radical. So what do you have to do for that? Square it. Square both sides. And so what you would be left with, x equals 81. And that would be your final answer. Moving on, we have two-step radical equations. So before squaring both sides, the radical term must be isolated. So it's basically the same thing as what we went over a little bit earlier, but instead of like just a isolated two sides, you need to solve it for yourself. So let's say radical x plus 3 equals 7. So minus 3 on both sides. Radical x equals 4. And what else is just that? And so you square it, get rid of the radical, then you square this. So x equals 16. Example 2 is 2 times radical x plus 4 minus 3. So what do you have to do? Add 3. And you'll be left with 2 radical x plus 4, which equals 14. And then you divide radical x plus 4, or I mean 2 radical x plus 4 by 2, this side by 2. What you'll be left with is x plus 4 equals 7. Once again, square, gets rid of this. This becomes squared. And what you're left with, x plus 4 equals 49. You subtract 4, and your final answer would be 45. Next up, we have a more complex radical equation. So, what's different in this case is it's involving a linear term. So, radical x plus x equals 6. Once again, isolate one side. Isolate the radical. Always isolate the radical. And square it to get rid of the radical. What we're left with is 36 minus 12x plus x squared, if you just FOIL. So, you just subtract x and rewrite x squared minus 13x plus 36 equals 0. And so your finals will be x minus 4, x minus 9 equals 0, and your solutions. In this case, some answers that you get from this form, remember that some of them are false. you have to plug both in back into the equation. And if they do not equal 0, well, then you cross it out. So when you substitute 9 in the original equation, the solution does not work out in the original. You can either use this, or you can use this. I use this just to be sure. And so what you have basically left with is like, if you plug in radical 9 plus 9 equals 6, plus 9 equals 6, and 12 does not equal 6. So in this case, reject. And 4 would be your only solution for this answer. That means for only solution to this question. Next up, we have radical equations involving two radical terms. So you have to isolate one of the radical terms and then square both sides very carefully. And then you do it again, you isolate the other radical term and then square it again. So it may be a little confusing, but let's just do it. What are you left with? X plus 1 equals 5 minus x minus 4. Okay. So you see that how we have isolated right here and isolated right here. So we square it. Square both sides. And what you're basically left with is x plus 1 equals 25 minus 10 x minus 4 plus x minus 4. If you just FOIL. Right? This times that cancels out, the radical cancels out, only the number remains, x minus 4. And then you just FOIL it out and you get this. Once again, you make sure that this becomes like 0, so you just move everything over. And what you're left with is, what you have to do is just minus x, cancels this out. So what you're left with is 1 equals 21 minus 10 x minus 4, basically, right there. Subtract 21. When you look at negative 20 equals negative 10 x minus 4 divided by negative 10. Oops, sorry. And what you're left with is x minus 4 equals 2. And then square it again, get rid of this. And x would equal 8 as your final answer. Okay. Super simple. Let's move on. So next we have the graph of a square root function. Since radical, whatever, only evaluates to the positive square root of a number, the y-coordinates of all the points are greater than or equal to 0. So it would be looking like this. Once again, if you wanna graph, just like that. Let's say just use a radical x in this case. Graph, and it looks similar to this. Okay. Oops. So next, we have transformations of the square root function. So it's very similar to that end of topic unit that we had like a video ago. It's just regarding transformations. So x was 2 is basically this, but shifted 2 units to the left. On the other hand, this will be shifted 2 units up. In the other case, this minus 2 will be shifted 2 units to the right. And then this will be shifted 2 units down. It's very simple to understand. Okay, let's move on and briefly discuss how to graphically solve radical equations. Okay, so what you have to do is basically the same thing. You can, let's say you have a problem like this. your teacher asks you to solve it graphically, what do you have to do? Plug this side to y1, this side y2. That simple. Okay. What you're left with is this. Sorry about that, 1 sec. Okay, sorry, I made a little mistake. You have to isolate first. Oh, I forget about that step all the time. So, right, isolate the radical. And that would be your final, and you just plug it in. Super sorry. And then intersect, second, calc, intersect. And then whatever intersects at is your answer. Okay, so thank you for staying this far into radical expressions and equations, and brief little review on this unit. We went over how to simplify radicals, went over imaginary and complex numbers, we went over solving radical equations, and we went over graphs of radical functions. So stay tuned. The next little unit that we have is going to be trigonometric expressions and equations. I'll be releasing next Tuesday. Okay, so we're learning unit circle, trigonometry, like sine, cosine, all those features, locating points on a full unit circle, and all that. So stay tuned for that video. Thank you for coming in to Algebra 2, Lesson 4, Radical Expressions and Equations, and I will see you in the next video. Have a nice day. Stay safe.